Let's solve algebraic equations now. So solve for x. We're given 8x plus 7 is equal to 31. We have three terms here. 8x is our first term, 7 is our second term, and 31 is our third term. Remember that terms are separated by plus and minus signs only. So the three terms here are 8x, then positive 7, then 31. So of those three terms, I can see only one x term, which is the 8x. I'll leave the 8x where it is on the left-hand side. I have my constant of 31 on the right-hand side. I have another constant there, positive 7. To bring the positive 7 over to the right-hand side, I need to change the sign of positive 7. That becomes negative 7 here. So I have 8x is equal to 31 minus 7. Next line, 8x is equal to 24. 31 minus 7 is 24. Now, I need to divide both sides by the 8 here to get rid of 8 so that I can have x only on the left-hand side. So 24 divided by 8 will be on the right-hand side, and 24 divided by 8 is 3. So x is equal to 3 is my final answer there. Okay, again, let's look at another equation. 2 into x plus 3 is equal to negative 5 into x plus 1. So firstly, we need to multiply out the brackets. So we use the distributive law like we have done earlier. So 2 times x will give me 2x. 2 times positive 3 will give me positive 6. That's equal to negative 5 times x will give me negative 5x, and negative 5 times positive 1 will give me negative 5. Remember, a negative times a positive is a negative, and 5 times 1 is 5. So here I have 4 terms in this line: 2x, positive 6, negative 5x, and negative 5. So of my 4 terms, I can see that 2 terms are my variable terms or my x terms, and the other 2 terms are my constant terms. So I will take my variables onto the left-hand side. I have 2x here already, so that stays the same. I have negative 5x here, which I need to take over. When I take negative 5x over, that becomes positive 5x. On the right-hand side, I have negative 5 already, so I'll bring down my negative 5. But I also have a positive 6 on the left-hand side, which I need to bring over. That will change to a negative 6. So I have 2x plus 5x, which is 7x. Then I have on the side negative 5 minus 6, which is negative 11. I need to divide by the coefficient of x, which is 7 here, so that I can have x on its own here. So x is equal to negative 11 divided by 7. That's my final answer there. Okay, if we're looking at fractions, I have here 5 over x plus 7 over 3 is equal to 4. Now if I want to solve for x here in a fraction type, I need to again find the LCD. But before I find the LCD, I need to ensure that all 3 fractions that are given here are in fraction form. The first fraction, 5 over x, I can see as a fraction. The second one, 7 over 3, is a fraction. But the third one, 4, I need to put it over 1 to make it a fraction as well, so that I can clearly see all my denominators. My denominators are x, 3, and 1. So I need to find the LCD of x, 3, and 1. To find the LCD when you have variables and constants, you need to find the LCD for the constants and the LCD for the variable separately. So the LCD for my constants, 3 and 1, is 3. And the LCD for my variables, I only have x, so my LCD is x. So my full LCD is then 3x. So I need to look at each fraction now to see what's missing from the denominator. My first fraction has an x only. I need 3x. So x times 3 will give me 3x for my first fraction. If I multiply the bottom by 3, I must multiply the top by 3. For the second fraction, I'm given 3. I need my LCD to be 3x, so I multiply by x. If I multiply the bottom by x, I must multiply the top by x as well. Then my third fraction there, my LCD is 1. My denominator is 1. I need my LCD to be 3x, so I'm going to multiply the 1 by 3x. If I multiply the bottom by 3x, I must multiply the top by 3x as well. So let's simplify all of this. So my first fraction, 5 times 3 is 15 on the top over 3x at the bottom. My second fraction is 7 times x on the top, which is 7x, over 3 times x, 3x at the bottom. My third fraction is 4 times 3x, which is 12x on the top, over 1 times 3x, which is 3x at the bottom. So I have 15 over 3x plus 7x over 3x is equal to 12x over 3x. Once I have all my denominators to be exactly the same, I can drop off my denominators. So I will end up with 15 plus 7x is equal to 12x. Now this is a simple algebraic equation to solve. I take my variables onto one side, so that becomes 7x minus 12x, and I take my constant over to the other side, which will become 15 becomes negative 15. So 7x minus 12x is negative 5x. That's equal to negative 15. I'm going to divide by the coefficient of x to get rid of it. So negative 15 divided by negative 5 will give me positive 3, and x will equal to positive 3 then.